Zarin Brackman, CSC 480, displaying assignment 1. I am a grad student, so I had the additional heuristic here. This is an example of how the code works. Running breadth first search on easy. I'll run main again, do medium on UCS, and then I'll do main again, and I'll run the hard search on A star 3. And that'll produce an answer as well. So the code works, produces the correct answer path here. How I modeled my states is that a state is a list of tiles, and so the tiles in this case are called squares, and a square is an object that contains the index it sits at currently, the value, the index that it's allowed to move to the right, to the left, up, down. I also determine if it is in the correct position, so that's a true-false Boolean, and the goal index is where the value should be. So I evaluate this set correct position to determine if you are at the goal index here. And then the node object contains that state, which is the list of the tiles. I've got the parent node here, children, which is a list of nodes, action, which is right, left, up, down, depth, path, cost, expanded, grid. This grid is for calculating the Manhattan distance. I store the Manhattan distance, the incorrect tile count, estimated path cost, remaining, and I evaluate those for my heuristics. So my heuristic that I made as a grad student is that I'm using the Manhattan distance, but instead of just using them as one cost per tile move, I am saying that the cost is times the value of the tile, so 8 has to move 1. The Manhattan distance for that would be 8, and I'm evaluating that against the path cost that you have moved so far. So I'm adding those two together to get my evaluation function. All of my evaluation functions, after they're evaluated, just run through these sorts that I have down here. And like I said, the node itself evaluates the functions upon creation. The evaluate goal is called in the main loop, which I'm about to show you. So there are two loops. I've got a general search 1 and a general search 2. General search 2 is only for iterative deepening search. General search 1 is for all other searches. I do all my initial creation here, node dictionary, which I'm tracking previously visited nodes. I queue up my new node. I actually track max size for the answer. And then I do run through the loop that's in the lecture. So if it's empty, return nothing. Otherwise, pop off the node, evaluate the node. Otherwise, run the successor function, which is one of these searches: breadth first search, depth first search, uniform cost, best first search. They're very similar to each other. The only things that are different is after breadth first search, I start doing state checking, and after depth first search, I run the sorts on the queue. Each time I run through these, the children, especially on the state checking, the children get put into the node dictionary and are evaluated each time. So I don't create any duplicate states. With iterative deepening search, I call the same loop, but after I've gotten past this first is queue empty, return failure, I always reset the queue, and the queue, I reset everything and run through the search with another depth incremented. That is everything that I have to show you for the assignment. Thank you.